I'm Dr. Namita Agrawal, the DP coordinator at Pathways World School, Aravali. We have been using the TI calculator for over 6 years now, and we are quite happy with its functions. I think more than us, our students are very happy about it because this is a very dynamic calculator, and children being very techno-savvy, they enjoy using it, and they explore more than even we can do. Personally, I love the functions option that this calculator offers, especially the graphs, where you can zoom in and out of the screen. You can pull the screen to the left, right, everywhere, and you can even label the functions, shift the labeling anywhere. You can even make a scatter plot, do the regression on it. I think there are so many options that this calculator offers. I think it's when we find it fun working on this calculator, the students definitely do. And my ex-students have been telling me that all over the world we have been using the TI, and it's a good option to start using the TI at school level. It makes a smooth transition into the university for them. Thank you.
Good afternoon, I'm Pawan Mittal. I'm from Scottish International School, and I'm heading Maths department there. I'm teaching IB from more than a decade, and I was using Casio calculator. So almost 6-7 years I used Casio, but from last couple of years I've started using TI calculator, and I've found that this calculator is comparatively much better. Due to different reasons. Number one, I can see the high resolution. Number two, the fast processor. And the most important, it always comes up with different colors and different, I'll say, even like some sort of uniqueness is always there in the calculator. And in the latest model, I've seen there are better graphing packages which are being there. So it's a great experience to use TI from last couple of years. Thank you.
Hi, I'm Ankita Sharma, IB teacher. I'm teaching at Neelja Modi School. If I talk about TI Inspire CX Calc GDC, it's quite fantastic. The features are quite user-friendly. The kids are finding it really very, very comfortable to use it. If I talk about the 9th graders, those who are doing the international math, and they are using the GDC for the first time, they are finding the applications to be very, very user-friendly, and they are finding it very easy to access most of the applications which are there in it. And in your IB also, the students are finding it really, really fantastic. And as compared to other GDC, it is quite easy, accessible, as well as quite easy to use. Thank you.
My name is Daniel Flynn. I'm head of mathematics in St. Joseph's International School in Kuala Lumpur in Malaysia. I've been teaching maths for 8 years, and I've been teaching IB for 4 years. And in the 4 years I've been using TI calculators. The first year I was using TI 84, and then I started using the Inspire. Well, my school started using the Inspire, which is funny because it was very difficult to change over. But once I've changed over, now I use it in my school, and I would find it very difficult not to use the Inspire. I guess my favorite things about the Inspire are, the first thing is that it's very easy to use. If you want anything, all the functions are in the menu. If you want to entry of any sort of mathematical symbols, they're all in the utilities. So everything is where it is. The second thing I think is the graphing window. It's very, very easy to use, easy to interact with, and you can plot anything to your specifications, whatever you want. The third thing I think is a visualizer, that I use that mostly in the classroom. If I want to teach students how to use a calculator, it really, really helps that I have the visualizer on my board, clear for everyone to see. The buttons key in. As I press the buttons, it shows red. So it's very easy to teach calculator skills to students using that software. Obviously, another couple of things are the huge amount of resources out there, the videos on YouTube, the TI, the education.ti website, which is full of stuff for teachers. So to be honest, it's really the most supported, most powerful, and best calculator.
My name is Anjan Chaudhary. I am heading the maths department at the Doon school. This TI workshop on Texas Instruments has been quite a meaningful workshop for me. The tools on the TI, which I am not familiar with, I have come to know in this workshop, and I intend to use it for my students. At the end of the day, one of the reasons why we do the IB is for the students, and this is a new tool for me, and I would like to keep using it for the betterment of my students. The TI Inspired CX has got a nice tool called sliders, and the best part about that learning is it's a dynamic learning tool. So it allows a lot of movement which is very difficult to draw on the blackboard. I feel that in the modern times where education systems are changing, this tool needs to be used quite relevantly and also in a time-bound frame in the classroom so that the students are familiarized with the use of this tool, and at the end of the day it will benefit their actual learning of mathematics.
Hello, I am Harmeet and I'm working with Heritage Experiential Learning School. I'm teaching maths, AI and international mathematics courses for the past 2 years there. So when we talk about TI, the Texas Instrument Calculator, it's been introduced to me 2 years back, and I don't use the hard handheld version, but what I use is an emulator or a software that I usually take it up in the class through a projector, which my whole class can see easily. So why I'm using TI is, so it helped me with various basic features that other calculators also do provide, like finding the intersection points, finding the maximum and the minimum, and let's just say 0. I use it to do regression, modeling, but what else I like, the TI features that I like is like curve tracing and all, which students can take up for their IAs and extended essays. When IB talks about use of tools like GeoGebra and Desmos, all these can be easily done through TI as well. So currently, my students are using TI as it provides them very good classroom learning experiences. The various tools through which we use TI, and the very important one is data capture. So we do data capture through geometrical figures on TI and then take that data on a spreadsheet. Once it is taken on spreadsheet, we can also do regression on these scatter plot features that the TI provide, and ultimately that leads to graphing of that particular data. Once that is done, you can also do predictions through drawing tables. Rest, I think everyone should also go for TI CAS calculators, because it provides you better learning experiences in the classroom. It provides you much better tools, and with the new IB guide also says that TI CAS CX2 is also allowed, and what we can do is we can later on put it on test mode while the students go for exams. So I think, yeah, for me TI is I think I prefer TI, and I will explore as much as it can. One of my friend has recently actually told me how you can use innovators also, and I'll try my hands on that also, maybe TI programming. So yes, I will recommend it. Thank you.
Hello and good evening one and all. Welcome to our today's webinar hosted by Numerical Analytics Instruments Private Limited. Thank you all for joining with us, where we are going to focus on the usage of TI technology to solve the problems involving the investigation and the modeling. Okay, so let me first introduce myself. My name is Jyoti Mewara, and I am working as an education technology consultant at Numerical Analytics. So the Numerical Analytics, we are the leading providers of modern education technology and the analytical technology. We have been around 10 years and working with many educational institutes, also with corporate organizations, and to implement the education technology and the analytical solutions. Our head office is in New Delhi and our main office is in Malaysia. Basically, we are the sole distributors of Texas Instruments, which include scientific calculators, graphing calculators, and the financial calculators across India. Also, we deal with the vernier probes and sensors, which are compatible with the TI Inspire graphing calculators. Apart from all these, the other division of our company is analytical technology, where we support the research analysts to and provide the qualitative and the quantitative research softwares. The partners of numerical analytics are Texas Instruments, eViews, and Vivo, and TIPCO. As you all know, we are dealing with many IB and IGCSE schools across India. So here is the list of some of the schools who are the users of Texas Instruments from a very long time. Basically all the American schools, let's say American School of Bombay and of Chennai, American Embassy School of Delhi, they all are the users of Texas Instruments since a very long time. Also, the group of Indus International Schools in Hyderabad, in Pune, and in Bangalore, they are the users of Texas Instruments. Actually, the list is very long. So we have brought you some schools over here, the Kodaikanal School, the Oberoi School, Pathways, and the Calcutta International Schools, Stonehill, and many more. Before moving ahead, let's have a quick view of the TI Inspire handhelds. One more thing, we will be having a Q&A session towards the end of the webinar, and the session is being recorded, and we will share the recording with all the participants. Basically, the Texas Instruments graphing calculators, these are the powerful tools which are used for learning, better visualizing the concepts, let's say in the maths or as well as in the science. So this is the latest model of TI Inspire family, that is the TI Inspire CX2. And you can see its keypad is basically divided into 3 different zones. The top one is the navigate zone, then the down below is the math and the numeric zone, and the down below is the alphanumeric zone. So in this keypad zone, you will find various different types of computer-like keys. And yes, these keys function same as they do in the computers and in the laptops. The important one is this control key. This is this blue key. Basically, this key is used to access the second function of that particular key. Suppose I want to switch off the calculator. So what I will do is just press the control and this home like key to use this off. Also, apart from that, you have tab key, which is great for navigating between the options. Then you have this escape key. This key is helpful when you come. It helps you out to come out of the screen. And you have more of the shift key, delete key, space bar, and they work same as they do in the computers. Apart from that keys, TI Inspire also have this keypad layout. So the other keys are, when you look at the control key, just below the control key, there is an equal to key. So whenever you press this control and equal key, you will get the relational keys. Beside that, you have the trick key. This trick key consists of all the trigonometric functions into it. Apart from that, you have the pi key, where you have all the conversions, pi, theta, and the punctuation symbols even. When you come to the right hand side of the calculator, beside 9, you will find this math template key. Whenever you press this math template, this will show you like that. So this key comes up with the options like matrices, differentiation, integration, maybe exponentials, and many more. And the most important one is this catalog key. This is a book-like key. This key is majorly used for finding any command, or suppose you don't find it anywhere, or you are unable to search it under the menu option, then this catalog key is very useful. This catalog key also provides you the syntax of that particular command. So whenever you're stuck anywhere, you can just press this catalog key and you can get the syntax as well. Also, I would like to inform you all that due to this COVID-19 situations which is happening across the world, Texas Instrument is providing the free resources to the teachers and to the students as well to continue their teaching and learning remotely. So what you can do is you can avail the 6 months subscription of the software in your laptops from the website. The website is education.ti.com. So whenever you go to that website, you will find the two different options. Either you want to select for the teachers or you want to select for the students. Once you complete the process of downloading, you can use the software for 6 months. One more I want to make you a note of: from this year onwards, the CAS models, that is of TIA Inspire, that is the TIA Inspire CX2 CAS, and it has been approved in the IB board. As we have an option of disabling the CAS mode, and after disabling, it would work same as the CX model. Also, you can disable that CAS mode during the examination as well. So moving ahead, let's explore some investigation and the modeling activities by two of our T-Cube trainers, Mr. John Paul Raj and Mr. Jimmy, who will be sharing their valuable insights with us today. So let's welcome our first speaker. Mr. John Paul Raj from Cathedral and John Cannon School, Mumbai. He is a math teacher and also one of the T-Cube trainer from India. He has master's degree in mathematics from Mumbai University and is pursuing on a course on mathematical mindsets from Stanford University. He teaches IB Math, IGCSE International Math, and Advanced Placement Calculus, and has taught in many reputed international schools like Woodstock School, Kodaikanal International School. He is having 17 years of experience and is very passionate about the technology. And he had used TI products and is familiar with the TI ecosystems since 1997. So over to you, John.
Thank you, Jyoti. And very, very, very good evening to everyone who's here. Very happy to see such a wonderful group. It keeps increasing, and suddenly I keep, that numbers, when it increases, suddenly, I'm all about numbers, and these days, every time I see a number increasing, I suddenly start getting nervous. And when I saw the numbers, I also saw two of my students here. So that even adds to my nervousness. So never mind, I'll ignore what I'm feeling right now. I'll just jump right into here. I'm really excited about this evening and what we've planned for you. So if you have a notebook, a notepad, or some writing material next to you, just keep that ready. Whatever you see here today, today, you probably may have already seen it before. For some of you are experienced TI users, but maybe there are some new things that you might just that come to your mind. So if you don't have a handheld near you, or if you do not have a software, perhaps this is a good time to just make notes and then try it out later. Okay. Also, it might be a little tricky, because you're watching and then you're trying to do it at the same time. Maybe something you'll miss out. And also, like Jyoti said, mentioned earlier, that since the video will be available, the recording of this video will be available, you can always go back and check it out. But I always tell my students, keep a notebook or a notepad or some writing material open next to you, so that some idea comes to your mind, or maybe even some question, because we have a time for questions later on. Just make a note of it, just jot it before you forget it. Okay, so that's just a little bit about how we're going to do this webinar. I will be talking about the paper 4. All right, so this is 0607 that we are focusing on today, the International Math Curriculum, and the calculator is allowed for both paper 4 and paper 6. My colleague out here, Jimmy, will be talking about paper 6. So I will focus on paper 4 and a few questions from paper 4, certain features of the TI Inspire. Right now, I've just opened up the CX non-CAS software, because, when it comes to the examination, I think many times when I speak to teachers, they say, oh, but the CAS will be switched off and it will not be of any use. And trust me, like it was mentioned earlier by Jyoti, that it's a lot of fun when you're actually working with CAS. Even when those of you who saw the video of people who are using the Texas Instruments, I have always asked my students to buy the CAS. Even in our school right now, the new batch of students who've come in for both IB as well as the IGCSE students, we encourage them to get the CAS because it's an experience in itself. So if you have the mindset that, we are not just here talking about exams, but the experience of learning, the experience of investigating, the experience of inquiring, I would strongly recommend the CAS, and especially because I think keeping that in mind, that is why I think IB has allowed the CAS version, because the learning experiences classroom should be inquiring, the inquiry model and the investigation model, even if it's questions that the students may not necessarily use the CAS model later on. So I would strongly urge you, if you're a student or if you're a teacher, recommend you to go ahead with the CAS model, because in the classroom you will have a lot of fun with that. Okay, and the students will also benefit with that if they're doing their IAs. That's for the IB program, as well as for the IGCSE program. I believe your classroom activities will definitely go up different levels. You can really make it a lot more fun. However, today the software that you're seeing right now, which I've shared, is a non-CAS version. So some of the features that would possibly be available on the CAS will not be available right now. So that's just right at the beginning. I'm just making a disclaimer out there. For the questions that I'd like to talk about, or the features that I want to discuss for our time today, I've picked up some questions from the IGCSE question paper 4. Some assortment of questions, and first question is right there in front of you. I think this is from 2017 paper, and this is a very classic question where students are required to sketch the graph. So if you're a student and you're at this webinar, remember, sketching a graph is not about making a table and finding the coordinates of the points and plotting those points and then connecting those points and then figuring out what the graph is looking like. Instead, what the IGCSE as well as the IB is looking for in that phrase, sketch the graph, is use your technology, use your calculator, and to graph this function. And based on what's given here in this grid, they've given the minimum and the maximum values for X, the minimum and maximum values for Y. In that viewing window, copy down the sketch and then highlight some of the key features that you are seeing on your graphing calculator. So we'll jump straight into that and then try and answer some of those questions from the graph. So a graphical approach, okay, as far as we can do a graphical approach. Some of them will not be able to will not be possible using only the graphical approach, like one of the questions I've chosen for much later on, but at least the first question, we should be able to tackle it. All right, so having said that, I will switch between the screen that I have here and my calculator screen, because you may not be able to see this. I think a good idea is that if you want to keep this in front of you, why don't you take a screenshot of it? Okay, if you're watching this on a laptop, I'll just count to 5 on my head and you can take a screenshot of this question so that you know exactly which question we are dealing with. All right, so I'm counting five in my head so that you can take a screenshot. There you go, that's 5. All right, now I'm going to switch to my TI software, the CX. The first thing is that for those of you, I believe when we saw the entry, the participants today, there are some non-TI users. I just want to quickly run through what you would see. This is the opening screen. When you hit the menu, you'd see the main apps or the main options that we have. This is the calculator, the graph, the geometry, listed spreadsheet, data statistics, notes, and then the Bernie app. So we are just going to make use of maybe the first 3, maybe even 4th one if I have a little bit more time if I do a statistics question. So let's jump straight into the graph app, and that's what should pop up. All right, and a quick thing about here is that if I hit escape, that entry line goes off. What I mean by entry line is this line where you enter the function. All right, so I just have hit escape and it's gone. To get to that entry line, you hit tab. I hit escape again, hit tab, you'll get to that entry line. Okay, so tab will give us the entry line where you can enter the function. Now this is one thing I wanted to know. I find the TI interface very intuitive, and the reason, I think maybe I'll highlight this in this one question when we're solving this question. I tell my students it's very difficult to get lost in the TI Inspire. I'll repeat that again. It is very difficult to get lost in the TI Inspire. Because I tell them, when you think that you don't know what to do, hit menu. When you don't know what to do, hit menu. because whatever screen you're on, say for instance, right now we have the graph window, whatever screen that's in front of me right now, this is a graph screen. I hit menu and I can see everything related to what I want. So there's a graph entry edit, and if I even hit the first option or whichever option I'm looking at, I can still come to that same entry. Just in case if you didn't know about the tab, all right? It's very difficult to get lost using the TI Inspire. I'll illustrate that again. Say for instance, I added another page, Control Doc, and I added a notes page. I really love the notes page. I'll answer some of these questions later on, although I see something like that later. So this is not the calculator that I use in my school. That's all right. That's all right. I mean, we can discuss in the Q&A section, but Control G is also one of the options, but tab is just a shortcut. All right. So you can see the Control G later on for entering the function. I have entered a page, a text page here. This text page is, you can write. This is a notes page. And you can write down notes, and here is where I make my notes. You can just make those notes, and if you want, you can even format it. All right. So this is kind of helpful, but the reason I even show the notes page right now is because I want to show that menu. Do you guys recall when I was on the graph screen, what are the options I get on menu? All right, let me just go back to the notes page now. Now, when I hit menu, see what I see. Do you see? Okay, if you didn't notice, let me go back to the graph page again. Menu, you see all the options related to the graph, analyze graph, geometry, trace, and all those options. Now, when I come back and I go to the text page or the notes page and I hit menu, those are templates only related to the notes page. So I can enter a math box and I can enter some math function there, maybe a wrong position. I can enter something here, and the shortcut is command, and I can write down some equation here. All right, but the point that I'm trying to make is that the menu is like the flag. Okay, you can hit the menu and you'll never get lost. So let's get on with that question. Control G, like someone pointed out, or tab should give us the entry. I hit Control Division to give me the template for a rational function, and the function that we had chosen was 2x squared plus 3x on the numerator. So I'm just going to type that thing quickly, 2x squared plus 3x on the numerator. On the denominator, we have a product, x plus 2 and 3 minus x. X plus 2 times 3 minus x. All right, that is the function that's given to us, and that's the graph. Okay, you can move this here, there, wherever you find it a little distracting. In fact, if you want to even hide it, you can even hide it. Okay, what I did was I just hit the right click. Again, there is something I want to just speak about the right click on the software, because we're using the software, it's just the right mouse click. But if you're using the handheld, the options are from using control menu. If you hit control menu, you'll get the right click. But while we're speaking about right click, just watch why I find this calculator fascinating. If I hit right click on the space, just this empty space of the graph page, watch, okay? Right click on the empty space in the graph page. I'm hitting right click. I get a certain set of options relating to the space on the graph page. However, when I hover my mouse on the graph and I hit right click, watch that. I think that's pretty darn smart there. I mean, the calculator recognizes what are the options related to an empty space on the graph page as opposed to a right click on the graph. Here you go. Can you see that? So the right click is a great option to have, and I just showed the right click because sometimes you might want to use the right click and go fast. You can hide the expression if you want to. You can delete something, but never mind. We're not really interested in that right now. I just showed you certain features, and let's get back to our question. Our question was to sketch the graph, but there were certain minimum and maximum values of the x-axis. So we'll change that by just clicking on that, and I can make that a -6. I hit tab to go to the next entry. That was a 12. I hit tab to the next entry. That gives me the space for the maximum value of x, 6. Hit tab again, going to the minimum value of y as given in the question paper. I'll change that to -6. Hit enter. That's my graph. So what the student is looking is expected is just to copy down this thing on the graph on the question paper, and they'll get the credit. However, you know, the sketch, the word sketch should be interpreted in such a way that, you know, if there are other features like this x-intercept here, that needs to be labeled. Okay, so like I said at the beginning, you know, it's very difficult to get lost in a TI-Nspire environment. Why? How do I know how to find the x-intercept? Well, go to menu, and you'll find everything that you want to know about the graph. You know, and my students just explore it. You know, and I just give them the menu thing, and they say, okay, what do I want to do? They'll probably go through all of that, and maybe at some point in time they come to that analyze graph. Analyze graph. And if your students didn't know, and if students are here who don't know, the other word for x-intercept is 0. Okay, so let's, since we already spoke about 0, maybe you can make a note of it. Okay, so x-intercept, solution, what's another word? 0, we just spoke about it. Root, these are all synonyms. Okay, so I'm also trying to show this feature so that, you know, if you're making notes even in classroom, you can add the notes page, and your students can keep making notes on the notes page while you are you know, speaking about a question and doing that. So as we saw that 0 is another word for the x-intercept, we can just use that option under analyze graph. The way it works on the TI-Nspire is ask for a lower bound anywhere on the left hand side of the root of the x-intercept. You can click there, and the moment you cross that root, the calculator recognizes that there was a root that is crossed, and it will give you the coordinates of the root. So if you graph this thing on your answer script indicating the root, I think you should get the whole credit for that, because there isn't any y. The y-intercept is just 0, 0. Okay, these numbers here, these are just the first markers for the x-axis and y-axis. You can even change that. I can make that to make it nice and clean. I can make this too to make it nice and clean, so you can see how it can be arranged, so on and so forth. Cool. All right, moving on to the next part of the same question. I'll go back to my question paper, right? I'll go back to my question paper. Here's the next question. It says, find the coordinates of the local minimum. Find the coordinates of the local minimum. Again, you know, as I said before, local minimum is a feature of the graph. Let's go back to our menu. The menu is like a lighthouse. All right. When in doubt, just run to the menu. Okay. So the menu, analyze graph, and there you can see second option is minimum. So you go on minimum, and you look at where exactly is the minimum. It's kind of a very funny shaped graph. So even if you stretch it between this point and this point, look at the calculator using the same magic way of, you know, lower bound, upper bound. It already gave me the coordinates of the minimum. I can rearrange these things just to, you know, make it a, you know, just to, you know, create some space, but also to see that, you know, that minimum point is somewhere here. All right. So let me just do that again if you thought that was a little too fast. Okay, so I'm just going to go undo, 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 undo. Okay, that's gone. All right. Like I said, go to the menu option. That's like our lighthouse. Go to the menu, analyze graph, second option minimum, and it's using the same algorithm, asking for a lower bound and an upper bound. You know why it does that? Because what if a graph had more than one minimum point? What if a graph had more than one x-intercept? Okay, so it's trying to find the minimum value of the graph in that interval. All right. So it's asking you, tell me what's the lower bound and tell me what's the minimum upper bound. In that interval, I'll tell you what the minimum value is. Right? So in the same way, it's asking you when we did that root or the 0, tell me what's the lower bound, tell me what's the upper bound, and in that interval, I'll tell you what the root is. So within that interval, you specify, in this case, I've specified this interval and says, okay, you know what, that's the minimum value. Okay, so that's your answer for the next question, the next part of the same question as to the coordinates of the local minimum, and there the students have found it. Okay, now the next part is part C, which says find the equations of the two asymptotes that are parallel to the y-axis. I feel like asking the students this question because, you know, the teacher and me will never sleep. So if there is a student here, okay, here's the question for you. I know some people are busy asking questions, and what happens when the upper bound is above 0? We're talking about values of x. We're talking about values of x. Okay, the interval for the we are specifying values of x. Actually, the algorithm that the calculator is looking at is values of x. So values of x on the left hand side and the right hand side. So the interval is yeah, yes, for finding roots. Can you specify that question, please? For finding roots, because the roots has to cross the x-axis, no? When you're saying root, so if you can specify when finding roots if the lower and upper bounds have more than one root. Exactly, Mr. Ranganathan, let me just answer your question by giving another example on the same calculator, okay? The others, please bear with me. This is a very good question, but since I've mentioned that, let me just take a detour and add another page. Good to show another page. This is how you add another problem, okay? So you go to insert a problem, and suddenly the numbering changes from 1 point to 2 point, as you can see. And let's just add two graphs here. Mr. Ranganathan, great question. The others, please bear with me. I'm just going to put a graph, negative x square, whatever, plus x maybe, that's 2x, sorry. And there I've got a graph there. And then I'm going to add another graph. So I'm going to hit tab. Some of you said Control G. That's also good enough. Control G is good. Tab works for me. I'm going to add a cubic this time. That key x cubed. And let's just say we have a minus x. And there's a graph there. Mr. Ranganathan, are you happy? We've got, I don't know, intersection points many, and we've got a couple of other intercepts also. Okay. The red graph has got 2, 3 intersection points. So this is for all of you. Let me just zoom in a little bit by pulling the graph closer. So I'm just going to use the pull, and there we go. We can rearrange our, oops, sorry, there you go. I picked the wrong thing. That's my label I wanted to pick. Here we go. Ready, Mr. Ranganathan and the others? We want to look at the roots, right? So the red graph has got 3 roots here. And we're going to do the same thing, all right? So what I meant was going through menu, analyze graph, and the 0. And we're going to look at, it's asking, look at this intelligent calculator. I deliberately put 2 graphs, you know, but it's asked the first question, hey, which graph are you looking at? That's smart, isn't it? So let me say, you know what, I want the red graph. So I'm going to pick the red graph. And now it says lower bound. So I'm going to pick, I want this root. Okay, I want this root. So I'm going to take a little left of that root and a little right of that root. And there I've got that particular root. Okay. I do the same thing again. Menu, analyze graph, 0. Again, my smart calculator is asking me, which graph are you talking about? So I say, hey, it's still the red graph. And then I say, on the left, this is the root. So on the left of this one and the right of that root, 0, 0. You get what I'm trying to say? Go back to menu, analyze graph, 0. Which graph? This time let's play with it. Let's say, you know what? The blue graph. And let's look at this root. Left hand side of that root, right hand side of the root. There we got that root that is for the blue graph. I really feel this is so smart, because you know what? It really interacts with you and asks you, which graph are we talking about? So when you are asking, when the graph is asking the question, when the calculator is asking the question, lower bound, upper bound, it's asking you for the interval, x values between which are you looking for the x-intercept, or whether it's the minima or the maxima. Okay. I hope the question is answered. You see, even in my classes, I'm not really so pushing for what my agenda is. I want to make sure that the people who are listening to me have understood. I hope the question was answered, and if it's okay, we can move on and we can give some time later on for the questions. If that's okay. Someone asked a question: how did you get the right hand symbol so quickly? Great question. It is not easy. Okay, on the handle, it's not as easy. All right. So on the software, it's a lot more easier, but it takes some time to get used to that touchpad. Okay. So yeah, so you can press control. That's right. You can press control when you're hovering around it. When you press control, you would get the hand key, and so and so on and so forth. Is that okay? Press the cursor for some time. Yeah, if you press control and that would you get that. Thank you. All right. I want to ask a question to the students who are here. I believe there are students and teachers. This next couple of minutes, I want students to speak up, okay? Because the next question was about asymptotes. So if there's a student here in our participants list, what is an asymptote? It says, find the equations of the two asymptotes that are parallel to the y-axis. What is an asymptote? Or what is an asymptote that's parallel to the y-axis, to be more specific? Students? Any students here? Hello? No one's here? A line that meets the graph at infinity. Aha. A line that meets the graph at infinity. Thanks, Asmi. We cannot speak. No, it's okay. You don't have to speak. You can just write it on the chat. That's the nature of online learning, I guess. That's okay. Put your answer on the chat. Great. A line that meets the graph at infinity. Okay. Tangent at infinity. Oh my God. All right. I love these words. Okay. Keep thinking. An asymptote is a line that the graph of a function approaches but never touches. Nice. May I know what the question is? All right. The question is, what is an asymptote? I asked. A line which appears to touch but never touches the graph. X equals to, okay, thank you for the answer, but what is an asymptote was the question. Coefficient of higher power of x is 0. Okay, all right. A line that touches a curve at infinity. Wow. How will you define? How will I define? Okay, finally it comes to me. Okay, I'm just going to put a couple of things down. Here we go. If you like this, make a note of it. If you don't like this, even then make a note of it, and then we can discuss that later. Okay. Maybe it'll be a good idea if I just share something else. One sec. Hold on. Okay, first of all, okay, if you want to know more about asymptotes, you might want to join something else that I'll talk about later. But right now, we'll just briefly go through that asymptotes again. Asymptote primarily is an imaginary line. Okay, that's the first thing I want you to understand. Asymptote primarily is an imaginary line. By imaginary line, I don't mean an imaginary number. Okay, what I mean by that, it does not belong to the graph. All right, now you may have seen graphs like these. Okay, you might have seen a dotted line, and then you might have seen something like going like that and something like that. You may have seen a graph something like this, where there's a dotted line and you have a graph that goes up like that. Okay, and so therefore your answers are all, quite right. But let's give it a bit more meaning to it. Okay, this is a vertical line, so obviously it's called a vertical asymptote here. Okay, vertical asymptote. This is a horizontal line, and so in this case it's called a horizontal asymptote. Asymptotes are denoted by that dotted line or the dashed line. Okay, vertical, horizontal. Okay. there are different meanings for a horizontal and a vertical asymptote. Okay, there is also something called a slant asymptote. We won't go into that, or an oblique asymptote. But in the context of a horizontal asymptote, we normally say it is what the function behaves as it approaches infinity. As x approaches become very large, what's the behavior of the function? What's the behavior of the function? Does it become bounded by that? Okay, that's the meaning of a horizontal asymptote. But a vertical asymptote is when the function is not defined. Okay, so yes, they are the same things, but a vertical asymptote is when the function is not defined. And in our question that we're looking at right now, if you look at it, let's go back to that. It's actually asking for those values where the function is not defined. And someone directly pointed out, just looking at the denominator, we can say the function is not defined at x equals -2 and x equals 3. But the point of our webinar is how do we do it using the calculator? Okay, how do we see this thing using our TI Inspire? Okay, this was an easy question, maybe an easier question because we already had it in factors. But what if it was not factorized? What if the question was not factorized? What if it was a higher power than a quadratic? Okay, but the theory still remains the same. Vertical asymptote means when the function is not defined. So let's just assume that this was not factored, and let's just assume that maybe it was not, it wasn't quadratic, and let's use the idea that the function is not going to be defined for a vertical asymptote. So let's switch back to our GDC. Where is it? Where's my calculator? I hope this is the one. Okay, that's my calculator, that's my graph, and for this what I'm going to do is, without the TI, it is a complex question. We'll look at that later on. What we're going to do right now is that we're going to use a table. You know what I said? Right click and you'll get the table, because the right click is also a useful command. But I also told you that the menu is like my lighthouse. So I go to the menu and I look at my table. The table, you can have a split screen table. Okay, a feature, nice feature of the calculator. And here the first column is x values, the right hand column is all the y values, and you can see that when x is equal to 3, the function is undefined. So that's one equation. X equals 3 is one equation of the vertical asymptote. And if you just scroll up, and you can see the other value where function is not defined at x equals -2. It's a really nice way to figure out the vertical asymptote using the table. Okay, and since while we are at the table, watch this everyone, don't blink. When I hit menu, I'm on the table, by the way. I'm on the menu. Okay, remember the menu is my lighthouse. Look at the options. Can you see that? Right? I hit escape. Now I highlight, the borders on the table. So if I click on the graph, the borders on that means that's active. The graph is active right now. I hit menu, and the lighthouse gives me a totally different set of options. As I said before, ladies and gentlemen, it's very difficult to get lost if you're using the TI Inspire, because the menu is so intuitively driven. If you feel that you're lost, just go to the menu. Okay, it's what you need to do. So right now, I want to just shut down this table. So I'm just going to go to table and just say remove table, and the table is gone. Cool. All right, let's get back to that question. Okay, let's get back to that question. The other parts of this question was, there's another graph given to us. Gx is equal to 3x plus 2, and it is to solve that equation fx is equal to gx and fx greater than gx. Okay, so I'm going to go back to my calculator screen. Okay, on the same window where we have already entered this function, we are going to hit tab key, or the control G, as someone pointed out. Here we are going to write down the second graph, 3x plus 2. Okay, there's a nice straight line, a red line there for us, and we are asked where to solve where these two functions become equal. Where do these two functions become equal? And where do they become equal? How do we solve graphically? Okay, forget about the algebraic solution. Where do they become equal? Anyone out there? Any student? Intersection. Hallelujah. All right, when we speak about intersection, last time when we met with the IB teachers, I showed you an option. Okay, I want to just say something about it, because I'm so hitting on that word menu today. So I'm just going to use that word menu again. You know what? The menu, when you go to menu again, you see analyze graph, right? and it gives you intersection. Number 4. Notice the singular word. Intersection is singular. Intersections is plural, right? So if I use singular intersection, guess what? Same algorithm. Which intersection are we looking at? Which lower bound, upper bound? It's thinking in the same way. In which interval are you looking at the calculator is asking me the question, in which interval are you looking for the point of intersection? Okay? But because you and I can see that there are many more points of intersection, not just one point of intersection, I'll show you another way to get it in one go, all right? So we go to menu, and not analyze graph this time, geometry, and you see under points, it says intersection points, plural. How cool is that? All right? Plural, intersection points. And now it's asking me, and if you didn't notice, there's a little box on the top left-hand corner that gives me a hint. Click on the first graph, then click on the second graph. So let's obey. Click on the first graph, the blue graph. I've clicked there, and you know what? I'm just about to click. I'm not even clicked. Can you see that? I'm not even clicked. I've just come and it's already appearing. I click there and all the 3 points of intersection are there, bang, 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 in one go. So that's how you find all the 3 points of intersection. The solution for fx is equal to gx. Okay? Now, in order to answer the second question, my time's running out. I had planned to do one more question, but we wanted to do the question 6. But I'll just be able to solve one more part to this question. I had other questions. If there is time, of course, we'll come back to that later on. Okay, this is really I'm having fun answering your questions at the same time. But we'll answer one more question, then we'll move on to Mr. Jimmy, who will talk about paper 6. And if there's time, I'll be happy to stick around and answer your questions and show you some other questions, how we can use this calculator. All right. So what was the next question? The next question was to solve the inequality fx greater than gx. Can you see that? Fx greater than gx. Here, a little more cooler stuff, but bear with me, and we'll do the paper 6 questions, and then maybe we can come back if there is time available. So fx greater than gx is an inequality this time. All right, so I go back to my calculator screen, and let me just clean things up right now. It looks too cluttery for me. Okay, I know that gx is that red graph. I know fx is my blue graph. So you know what? Let's just hide this. Okay, so I'm going to hide this thing. I'm going to hide this thing. All right, so the labels are gone. This 0.93, negative 0.93 was the coordinates of that minimum. Let's hide that one also. There you go. We don't need it right now. And this was the root. So let's pick that and hide that one also. So I just hit the right click and I did that. Now we have 3 points of intersection because I need that. Now, how do we determine which graph is greater than another graph? Could you share your email ID at the end of this? My email? Okay, we'll talk about myself later on, man. Let's talk about this right now. I will. I didn't mean to put you off. I will. My details, I'll share that later on. Okay? How would we find which graph is greater than the other graph? A question to the students. Teachers also feel free to answer. Graphically, huh? I like to keep it interactive rather than, trying to focus on what I have to complete. I guess... I want to hear you guys. How do you know which graph is greater? All right, let me give you a hint. Okay, I need to switch to my fancy iPad quickly. Let me give you a hint. Substituting in the equation. No. I'm looking for the graphical. Which one function overtakes another function? Substituting. If the part of the graph is above than the great... Wait a minute. What is that answer? That answer looks nice. If the part of the graph is above that, then it is greater than that of the... That's nice. That is nice, Mr. Kumar. Graph on top. Fantastic, Mr. Ranganathan. Fantastic. I like Mr. Ranganathan's answers. He's always curiously involved. Graph on top. Excellent. For those of you who did not get it, bear with me. Here's something that I will just show you quickly. Okay. What Mr. Ranganathan's answer was, let's just highlight it, okay? Oops, something else has come out. Okay, here we go. Everyone just watch this quickly, all right? So you have a grid, and let's just say there's a function fx, and then there is another function g of x. Okay? Which graph is greater? Obviously, we say the graph at every value of x, for every value of x, the pink graph is above the blue graph. So fx is greater in this case for all values of x. Is that right? Fx greater than gx for all values of x. Now let's change that slightly. All right? That same thing, let me make it this way. You have that thing as my f of x, and I now make it like this. That's my g of x. Now the question is, when is fx greater than gx? Where is it above? So we say, you know what? That's the point of intersection. That's the point of intersection. So any value before this point, the pink graph, is greater, and any value after the point of intersection here, the pink graph is greater. Is that right? That's basic theory. Now let's get back to our question. Because we have already found the point of intersection, look at the blue graph and the red graph. The blue graph is above the red graph before this point of intersection. That means before x less x, before x is equal to negative 2. All right, so all values below negative 2, the blue graph is above the red graph. That means fx is greater than gx. And then there is a vertical asymptote here. So from that vertical asymptote, x is equal to negative 2 to this point of intersection, the blue graph is above. And then after that intersection point, the blue graph is above. Okay, you know what? I am done with my time right now because I want to respect the time that's given to me. I will come back to you guys if we have some questions, but we need to move on. But thank you so much. I have some more questions and some more features I would love to show. But if time permits, we'll come back to that. If not, if there's any question answer session, or if you have any questions that remain unanswered, do email me, and I'll try to answer. Okay. That's all for me right now. If there's any time permitting, then we'll continue later on. Jyoti, that's all from me for now.
Thank you so much, John, and thank you so much for enlightening our participants with the useful and the interesting features of TI Inspire. Yeah, sure, we will be having a Q&A. And before moving to the next part of the session, let's have our second speaker, Mr. Jimmy, who is currently an employee of TI Education Technology. He had conducted over many workshops and presented the conferences and centralized events across Asia. He specializes in applied mathematics and has always had a passion in both teaching and the mathematics. And he loves to explore the technology and can be cultivated and implemented into the learning mathematics. Over to you, Jimmy. Hi, Jimmy. Your voice is not audible.
I apologize. I was on mute. I did not realize that. So sorry. Yeah. Hi, thanks, Jyoti.
Yeah.
Yeah. So please let me know if my voice is soft or is it, or am I going too fast?
Yeah. No, it's clear. Yeah. It's clear.
Right. Okay. Sure. Right. Thank you. Okay. So thanks everyone for coming for this webinar. Yes, I am a staff of TI, and I am based in Singapore now. So currently now in Singapore is 7:21 p.m. Supposed to have my dinner probably in about an hour time, I suppose. Yeah, so I hope everyone had a good lunch just now and good evening. And yeah, so I hope to go through this paper 6, the IGCSE paper, that you are able to learn some tips and tricks on how to actually explore the TI Inspire and use it in terms of investigating and modeling questions for the IGCSE paper 6. All right, so let's begin. Okay, so just a little sharing of how I'm going to do this presentation. So I'll be focusing, I have quite a few things to actually share with you all, and a few features to also share with you as well. So my team will actually be answering the Q&A questions or any comments you may have to chat. You can hear some background noise, okay, just give me a minute. Sorry, is it better now?
Yes, you may.
Okay, sorry. Apologies for that. Yeah. So yes, I was mentioning just now, I am actually doing. I hope to actually have my colleagues and my team members to actually be answering the questions as and when I'm doing a presentation. If you have any questions for me, do feel free to write down in the notebook as what John has mentioned earlier, or if not, write down into the chat and questions. And if I can, if my colleague will not be able to answer, and it's for me, I will answer it later as well. Right? Okay, so let's begin. So same thing, I'll also be toggling between the TI Inspire software as well as the question paper. Right, so the thing is, the TI Inspire, the screen itself has certain limit space to how much can you write on that. So in terms of clarity, I thought it would be better for everyone to actually look at the question in the actual PDF format. So let me change my screen. Give me a minute. All right, so I'm looking at the 2016 winter paper, paper 6, International Mathematics. And I'm looking at the modeling question. So for teachers who are teaching the IGCSE paper, and you may want to actually refer to these questions for your own reference, it's easier for you to actually go through together through the webinar. Otherwise, for the rest, you can actually, I will show the question once in a while as well. So do take note of it. Like what John mentioned, take a screenshot so if you need to. Okay, so this question is modeling, and we are going to model sea waves. So we are given the wave height of a sample of 60 waves in the order of size. So very nicely, the question actually helps us order the question in increasing order for 60 waves itself. So let me just, before I go to the question 1, let me just show you. John actually showed you just now. So I just want to highlight, even for the notes section, the notes application in the TI Inspire, not only can you type in questions and type in your notes and this, you can also actually, especially for teachers, you can actually copy, cut pictures, cut probably diagrams from different sources and actually paste it into your notes page for students. Like for example, you can actually, this can inline kind of create like a teaching material for a certain topic for your students. Right, so what I did was I actually did some typing of what's the questions about, kind of paste a bit from the picture to give a feel of what's this question. Right, so question 1, the question was asked to find, okay, first it says the mean height of the highest 1/3 of the wave in the sample is h. And for the sample of 60 waves, calculate h and show that it runs to 2.92. Before we go on, let's look at B as well. So for B, this is a something use H to make estimates. So comment on accuracy for the following estimates. So the highest, for part 1, the highest wave is approximately 2H. And for part 2, the highest 10% of waves have a mean height of approximately 1.27.
Sorry to interrupt you, Jimmy. You're working on the software right now, right?
Yes.
Yeah, your screen is not visible actually.
All right, okay, I apologize for that.
Yeah.
Let me change the screen.
Yes, it's fine now.
Yeah, okay, so sorry about that. Yes, so yeah, this is what I'm trying to say. The notes section, you can actually type out the question as is, or like what I did earlier, I actually can cut and paste some pictures into your notes page. This is mainly more for teachers. Mr. John Paul, as you mentioned just now, you can actually key in the notes during lessons and so on, right? So let's do the first one. Calculate H. Yeah, you want to first find H and show they run off to the value of 2.92. Right, so for this case, for simplicity, I'm not going to actually key in all the value just to save a bit of time. But we're going to actually use the list and spreadsheet app. So I created this, but just to show you a quick one, how to go to list and spreadsheet. I'll open a new page. There's a lot of different ways to open a new page in your TI Inspire. especially if you're using a handheld. So for those who have not attended my webinar before, just to share with you that this TI Inspire works very similar to a computer. So like for example, Control Z is undo, Control Y is redo, right? Undo, redo. Control N is to create a new document, and when you press document and I go to page insert itself, Control I is also a shortcut for page itself. Okay, so there's a lot of different ways, but the one that I prefer is Control Document. Control Document, above it you'll see plus page. That also creates another page. Right, so I'm using this expression. Okay, I'm just going to go back. I'm just going to show you how I can go to this page. For those who are new to the TI Inspire. Okay, so to save some time, I actually key in the values of the top. Sorry, give me a minute. Let me share this question. Highest 1/3 of the values in the sample. I actually key in the values for you. Okay, to save a bit of time with that. 2.06, 2.15, 2.18, and so on. So now, how do we find H? H is the mean. Okay, so of course you can calculate and manually use the formula. You have 20 values. It's also simple. But let's say if you're supposed to do this question on the calculator, the method to do so is press menu. Right. So what John showed just now, different pages has different menu functions. So for this spreadsheet, these are the menu functions. For those who have been using, you can actually go and explore further. I will not be able to showcase everything, but you can. I would strongly recommend to explore the different functions available in the calculator. To calculate the mean, I go to statistics, number 4, 1, stat calculation, and 1 variable statistics. So number of lists is 1. The list is basically the columns. So the X1 is basically the list that you want to find the mean. This case will be H. Or if let's say if you forgot what's the name of the column, you can also type it out. A with the square bracket. Right? And the rest you can leave it as this. This one here, first result column, this is basically the column that you want to display the values. So once I'm satisfied with this, I press OK. Let's go to the right. These are your values. So H is actually 2.9185. So you go back to the question. 2.1985 round off is 2.92. Right. So over here, I just want to add on a bit. With this feature of statistics, 1 variable statistics, for teachers who do, especially the IB teachers, if you do use 2 variable statistics, you can actually go to, so if you have bivariate data, you can do 2 variable statistics, and you can do different regression here as well. We'll come to this later. Okay, so that's for 1A. So for 1B, the highest wave is approximately 2H. Right, so you go back to the question, okay, it's a bit difficult here, but if you see on the screen, the highest value is 5.20. So we need to show that H multiplied by 2 is approximately 5.20. So how do we do that? What I'm going to do here is I'm going to, okay, take note, X bar is a H here. I'm going to create a new page, a calculator page. And I'm going to define H. Okay, I'm not going to use H. Reason being is because if you see, H here is bold and non-italic. What does it mean? It means that H is already been defined. Let's see here in another alphabet. Let's say A. So A is an alphabet. I have not defined a function to it or a value to it. So it's shown as non-italic. So it's italic and non-bold. So that's a little quick trick here. I'm pressing on the variable button, the calculator, beside the delete button. You list out all the different expressions over here, and what has already been defined. And for this particular question, just by listing out all this, the calculator actually automatically stores all these variables for you as well. So in this context, you don't have to redefine your variable h or so on. If you want to, for simplicity, I'm just going to put h1, right? Just for understanding. But h1 here, I'm going to store it. This is the store button. So just to show you how I do that. Control template button beside the button, the right of button 9. This is defined as. I store it as x bar, the mean. You don't actually have to do this, but if let's say for easy understanding, you can do that. Okay, 2.9185. Now, what we have to do. Now, what we have to do over here. Sorry, something my voice is cracking. You let me hopefully this is better now. We just want to multiply 2 to this value and see if we get the number 5.2. 2 multiply. You can either type h1. This case is not capital sensitive. Right? So small h1, big h1 is fine. H1 5.83, and you see that 5.837 is not the same as 5.20. Right? So that's for part 1. So this is not true. Part 2, the highest 10% of waves have a mean height of approximately 1.27. So now what we're going to do is we're going to actually calculate this mean height of the highest 10%. Okay. The thing is that for this question, it's very nice. It actually lists out 60 waves in a very specific order. If you notice, there are 10 values in the first row, and there are 6 rows itself. So the top 10% will be the 6 values counting backwards from the bottom: 5.2, 4.76, 3.41, 3.26, 3.23, and lastly 3.21. So these are the values you can get. Okay, unfortunately, this is an image, so I will not be able to cut and paste here. But over here in your spreadsheet, you can actually copy and paste from here. So what I'm going to do, of course, if you find this bit of a hassle, you can still type it out if you want to. I'm going to create a new column. Okay, what I do is I press Shift. I'm using a computer, so it's a lot easier. I press the Shift button and calculate the 6 values. Right, so A15, A20, these are the values you want. The top 6 values. Control C. I won't recommend to put it in this column, because otherwise it'll be very messy. Let me leave some space in between. I'm going to put it in this column here, right? And Control V. So my values are there, the top 6 values for this. And if you want to, you can label it as, we say, H new underscore, for example, or even more clearer, H top 6. And now we calculate the mean of this. So the mean of this, same thing we do. Make sure your cell selected is an empty cell. Press menu, statistics, set calculation, one variable statistics. I'll use H top. And yeah, let's use column H. So now your X bar is 3.855. All right, so now what we do next, we just have to calculate. Does this value equals to 1.27? If you want to, you can actually, just a little shortcut, you can actually copy this value, press Control C and Control V. If you want to, little shortcut, especially for teachers using software, is a lot easier. I'm going to place this value here first. I mean, I'm just showing you a different way of how do you call values from different places. You can do the same thing when define your H1 or maybe H2 this time into your X bar for this new H top 6, or you can just call the X bar to the new H top 6 as well. Up to you. Right. So over here, what I did was I just tried to do another way where I just copy and paste from the Excel file. So what I do now is I want to actually take this 3.85 and divide it by, okay, there's a lot of ways to do it. What I'm going to do is actually going to divide this by h and see whether do I get 1.27. Because if it just give me 1.27, then we get the answer, right? This h value is actually about 1.27, the value of h, multiple of h. Okay, press divide, you can press control divide to get a fraction. h1. 1.32, right? It's not 1.27. Okay. Of course, you can also go and calculate 1.27 of this value multiplied by h1 and see do we get the same value of 3.855. Okay, we don't as well. Right, so there's a lot of different ways. Hopefully you can explore this on your own. All right, that's for question 1. All right, next. Okay, I hope I'm not going too slow here, and or I'm not going too fast as well. So I hope everybody can get in line with what I'm doing here. So next question, we have a frequency table of the different wave heights intervals, x meters, with the frequency for each of them. And we have 2 models for the frequency. So it's probably assumed that the model for this calculating the frequency is could be following A, or it could be following B. And the nice thing about this is that, okay, so the question asks us to sketch and label the graph of model A and model B accordingly. They gave us the graph and we have the parameters. So you can actually know what's your max value and your minimum value for your x and y axis. In this case, your x and f axis. Right, so when I sketch this graph, you'll be sketching a graph of y. Instead of f, you're going to use y. So just take note of that. Right, so let's go back into the here Inspire. Okay, so I just open up with a new graph app here. And let me just change the dimension of the window first. So what, for those who have paid attention to the earlier part that John has actually mentioned, double clicking the extreme values will allow you to edit those points. And you can just change to how you want it. Right, so for this question, 60, then I press the tab button. You go in a clockwise manner. So you go to the X maximum, this is 4, tab y minimum 0, tab enter. So this is the graph 1. All right. Okay, for simplicity as well, I'm just going to show you the graph of F1. I already did it in advance. If you want to recall what the function again, just check on the box itself. Right? The graph will be drawn. That's a quick one. How do you actually sketch the second graph? I press the tab button. For F2, we key in the graph as is given. So a quick one, 14 multiplied by x cube. Okay, so pardon me, I have the question in front of me, so I can see that. Okay, if you don't just pardon me for one, let me just type out the expression. Multiply by 2 to the power of negative x. All right. So you have these two graphs. Let's go back to the question for a while. So yeah, we sketch the graph. Okay, remember to label, right? The calculator doesn't label for you. So remember to label your axis accordingly, your x-intercept if there's any, y-intercept if any as well. Right? Okay, this one I think is I will go through quickly. John has already done this just now. How do you find the maximum frequency? So basically it's your maximum point. Oops, sorry. Go to go to menu. Sorry. Analyze graph maximum. In this case, if you have two different graphs, the calculator will actually ask you which graph are you looking at. So let's say we'll do the blue graph first, model A. So what we did just now, yes, right? We have to do a lower bound and upper bound. I'll just show you a quick one. It doesn't matter if you choose your, sometimes the students may make mistake. They choose the lower bound as upper bound and upper bound as lower bound due to oversight also, right? So the calculator actually will actually recognize that. So I want to purposely choose the upper bound here now as my lower bound. You see, automatically the calculator, if I move to the left, they will ask you, oh, you're actually looking for a lower bound now, right? And even hint to you that that's the maximum point you're looking at, right? So if that's the one you want, that. One question, what happens if we actually have, within our interval, sorry, just let me go back. I know it's not in this question, but what happens if we have more than one turning point, more than one maximum point in the graph in this particular interval? You think, no, the calculator will always take the leftmost. So just be careful. If you have more than one, you have to do it slowly for each of them. What we learned just now is that you have many intersection points. We can use geometry, points and lines, and intersection points, right? To find more intersection that have more than one in a particular diagram. Okay, like this, for example, right? But for maximum minimum point, unfortunately, we have to work out each of them separate. So same thing again. I'll do that. Find the maximum point of the red graph. Yep, that. So these two. Okay, so it's pretty straightforward. Now let's go to the next. Let's go to the question. Which model best fits the data in the table? Okay, just a little sidetrack now. So over here, this part of the question is more on concept, not really more on not into the investigation, not into the modeling part. Okay, I will go through briefly. This one I will leave to the teachers if you are going through this question on your own to explain further in detail where it goes. For this question, the answer is actually model B, F2. Reason being is because of the frequency. The frequency value, the Y value here, is actually lower compared to this. From the question, we see that yes, the X value is between 1.5 to 2, which is what we calculated, but the frequency is about 22. So the model A gives us a frequency of about 52, whereas model B gives us a frequency is about 38, if I remember correctly, which is actually lower. So model B is actually a better model. Not the perfect model, but the better model. So this is one of the reasons. I'll leave it to you all to actually explore some other reasons why this is true, right? Okay, and question 3, also very conceptual question. I'm just going to go through quickly. So wave machines mix wave of different heights and speeds. And this diagram shows the speed, meters per second for waves in different height. And we shown as such and such. So they say, without doing any calculation, write down a possible model. Right, so for this case, how do you actually find a possible model? This one here, okay, I apologize. It could have been due to the bandwidth itself. That's why my voice may be a bit fluctuating and breaking. Because the thing is that I've read my mouthpiece is already beside my mouth already. Yeah, I'm using a headset. So I try to, if possible, one possible solution is that this session will be recorded, so you can actually refer to what I've mentioned in the recorded video as well. Otherwise, in the Q&A later, we can also ask those questions, and I'll try to show it to you and explain to you later. Right? Apologies for that. At times, it was very difficult to understand what you were saying. Okay. Probably I will try to speak slower. Right, this will help a bit as well. Okay, so for this question here, again, it's a conceptual question. They ask us to write down a possible model for this graph without doing any calculation. And next question is, what does your model tell you about the connection between S and H? So S is the speed, H is the height. Okay, be careful. This question is a bit tricky. My first thought, I mean, without looking in detail, what the question is asking about sorry, not the pace, but due to the fluctuation in voice. Okay, this one I'll try to adjust my mic as I can, but I really think this is due to the net connections and the bandwidth is ongoing. I apologize. I'm in Singapore right now. Could have been high bandwidth usage at the moment. That's why. Okay, so coming back to this. So this question here, one common mistake. Yeah, even I myself, I actually did overlook it at the start. I saw the graph. It seems a bit sinusoidal. I thought so at first. But if you read the question carefully, it's actually speed against height. Speed is not dependent on height. Right, so this model here, it should be a straight line, probably at 3.2, estimating it. It should be a straight line. It's a constant equation. Yeah, a constant equation itself. Okay, so what does that model tell you? It should not be a relation between speed to the height of the wave. Okay, now this is where we come to more usage of the calculator. We have another model, D and S, given this data, and we actually plot them out. It's actually the graph looks something like this. Question says that there are 3 possible models for this. Which model best fits the data? So this is more about the best fit model, and we want to actually see which of these 3 equations give us a linear expression. More specifically, should be a upward sloping linear expression, right? It shouldn't be a curve, and so on. But I want to show you some exploration that we can do for this question. So let's go back to the TI Inspire. So I've already keyed in the data, okay, to save us some time here. So what I want to do next is, let's sketch out the scatter diagram as what's sketched in the question as well. I'm going to create a new page. We're going to use a new application now, add data and statistics. Over here. Okay, first, this your earlier defined functions or values are also listed, but we do not want that. Okay, so what the question want? The question asks to stretch what against what. Okay, also for this question, they actually give us the diagram itself. So you can refer to see which is your x-axis and which is your y-axis. So depth is the x-axis, S is the y-axis. So it's D to H. Sorry, D against S. What I'm going to show you now is we're going to try to draw the same scatter diagram for these 3 different models. A little shortcut here. I'm going to actually do the equation onto the entire column rather than evaluating each of them respectively and calculating in the calculator and then key inside. We're going to do it all together. This is a calculator that probably will be useful for time purposes. We need to save some time in calculation. So let's define this first. So the first model is a square root model, square root D against S. So I'm just going to define it as square root D. Right, just press enter. Then over here, I'm going to square root D. Okay, so over here, they ask you, are you referring to a column or are you referring to a variable? You want to use variable. Right. What happens here? Yeah, see, it squares all the value for you. Okay. Next, just to save a bit of time, I'm going to show the rest as well. Cosine D and D square. Cosine D and D square. This is equivalent to cosine of D. Should use variable, right? Okay. And D square. So I wouldn't recommend changing this. You can leave this here. I'm going to create another data. I'm going to create 3 scatter plots now, and we're going to observe each of them. So we're going to create 3 scatter plots. The first one is square root D against S. Oh, this is very nice. Let's see the rest first. Cosine D against S. Decreasing. Weird. Not doesn't seem linear as well. D square against S. Positive, but also not linear. Right. So from here, which models best fit the data? It seems like S equals to A square root D plus C. That's the one we want. Seems linear here. Okay. Okay, I'm just going to sidetrack a bit. Just give me a bit of time here. I'm going to sidetrack a bit over here to actually share a view, especially for teachers. How do we use the TI Inspire to do some concept explanation? Okay. So what I'm going to do is that we can actually, in your scalar diagram, analyze. I'm going to add a movable line. So for students who are new to the regression line, this would be something useful on how do you actually try to draw the line of best fit. Okay, I know if you try to draw it on a piece of paper and ruler, when you try to shift a ruler, tilt it more to the left, more to the right, it's very difficult. Especially if you do many times or you do it at night, your eye probably will be a bit tired trying to do this. So this is actually a useful feature in the TI Inspire where you can actually try to create the best fit line. So if your cursor is in the middle, right, you can actually click on it and you can shift up and down how you want it. Okay, let's say I want it somewhere here. And then maybe you want to shift it, rotate a bit clockwise. So move your cursor nearer to the end, click on it, the hand symbol is there, drag it down. See, you actually start to shift now. And same for the other side, shift up. Yeah, so this is just an estimate here, but this is the estimate best fit line for this equation. We probably can use this equation to do some calculations later. Yeah. But of course, sometimes, especially for math students, we are very particular with getting an accurate answer. We want to know the correct answer itself. We can do that. The quick trick here, menu, analyze, regression. You can use either mx plus b or a plus bx, whichever you prefer. I can use mx plus b. Oh, wow. So close. This was my line. Yeah. Okay, I'm going to make it a bit more obvious first. But if you click on the line, the equation of the regression line will actually appear. This is the accurate answer. And what's the value of A and C here? Back to the question, you can actually use it accordingly. Take note, this x here is square root D. This s here is just s. Okay, so that's one quick one. Will it be easier to draw the 3 graphs on the same axis and determine? Okay, for this case, we can whenever you do the data and spreadsheet application, you can always tabulate at most 2 data at one time. Right. So the thing is, if you want to have 3 data, either one suggestion is to use the split screen function. The split screen function, and do some and actually put 3 graphs all at the same page, all at the same screen. Like for example, maybe layout 4. But if you want to show all on the same thing itself, it'll be very complicated and messy as well. Okay, so that's why I would recommend the calculator also doesn't allow that. But maybe for this question, and usually for regression question, we do not need to actually have all 3 of them to see which best fit model. We actually can just look at the diagram itself and see what which model best answer the question, best fit the data. And I guess a quick one for IB teachers, there's a little additional information here. If you want to find Pearson correlation and coefficient value, sorry, we can do that as well. Let me do a quick one of finding the Pearson coefficient value for square root d to s. Menu, 4 for statistics, 1 for stand calculation. This time I'm going to use 3 linear regression. You can use 4 as the same. My x list will be square root d. My y list s. See, over here, even save the equation into your F3. You can actually plot this out later. And I'm going to just draw it on, list out the values on G. Right? See, it tells you your M value, your B value, oops, sorry, and your Pearson correlation as well. So this is not in the IGCSE, but I thought this is something useful for IB teachers if you're doing statistics. Okay. Next, just the last part here. Okay, I don't want to spend too long. I think I've been covering quite a bit as well. The last part of the question, let's go back to the question. Let me change my screen. Yeah. So which, this last question. This photograph taken at different times show a small island in the bottom right-hand corner. The wave marked by the dotted lines travel towards the island, and on both photographs, 1 cm represents 100 meters. So for this question, it seems like we have to do actual measurement. We are given the first picture at 13 hours, 5 minutes and 3 seconds. Second picture, 13 hours, 5 minutes and 43 seconds. So it seems like 40 seconds to travel. Okay, of course, we will need to actually have actual paper and measurement to go and calculate it. To save us some time here, the calculations, the distance between this line and this line, if you truncate it over, is about 1.7 cm. Okay, that's the answer. So 1.7 cm gives us 170 meters. Okay. So now, what we want to do, okay, let me just switch the screen back to the TI Inspire. Yeah, I just put 170 there, just for our own reference. So we want to first, the question asks us to find, sorry, I think I switched too fast, apologies. Find the depth of the water. Use this question, use your equation in part D, part 2 to calculate the depth of the water. Basically, use this model that we want, because this is our answer for part D, part 2, and use this to find D. Right? But over here in this question, what we have so far is the distance between this line, this dotted line, to the next line after 40 seconds. Basically, we have distance, we have time. We can actually calculate speed. So let's do that. Let's calculate the speed here. Simple calculation using the calculator app. You can type out everything, but just to show you that you can actually copy down your previous expression by pressing the national pad, go to the expression that you want, press enter, divide by 40 seconds, right? So the speed is 4.25 meters per second. Next, now we want to solve the value. We have the expression, right? We have actually saved it. This is a quick one if you recall. Oh, sorry. Let me just draw the graph. See, we have actually saved the equation of the regression line for square root d against s in F3, where we actually calculate the correlation coefficient. Right. So usually I recommend using that method to find your M and your B accordingly, because that will help you save the equation. And usually for regression question, is a follow-up to ask you to do some interpolation or extrapolation. If it's safe in your equation, you can actually refer to this. So I'm going to have make use of that F3. So basically, the question asks us to find F3 of x such that this equation is equal to 4.25. Right? You want to okay, maybe I have to use x. I can use s. I can't use s. S is already defined, so sorry. So I'm just take x. We have to find the value of x, given that the speed is 4.25. Right. So to do this, Using a calculator, I'll use numerical solve. Menu, algebra, numerical solve. F3 of x equals to 4.25 comma x. The second expression here is what you want to find. Okay? And just press enter. 1.35135. Take note, square root, this means that this value found is the square root d. Right? Your question, the model that we use, go back to the question, square root d. So the value that you found just now was square root d value, but I want to find d. So just square the answer, and you should be able to solve the question. Copy it, square it, enter. 1.83. Okay, I actually have another example to show, but I think within the next 5 minutes, it's almost impossible to show another question. Hopefully, if we have the opportunity to show do more such webinar, I will try to show you more of different functions in terms of exploration and also in terms of mathematical modeling questions. How can we use the Xperiential to solve? As curriculums are moving towards modeling, TI on our side, we like to actually showcase how you can use the Xperiential to actually investigate, analyze, and also explore mathematics. Okay, with that, that's my time. I'll hand my time over to Jyoti. Thank you.
Thank you. Thank you so much, Jimmy. So we have some questions in a Q&A. John Paul, can you answer this? This is, I guess, question of a student. That do we lose marks if we show calculations anyways?
No, not at all. Not at all. See, nowhere in the question does it say use your UGC only to solve this or use only a graphical approach. However, you need to understand one thing. Look at the points allotted. May I just share that screen quickly, if I'm allowed to? And some of the questions, it's just one sec. Okay, let me just the document that I prepared. One sec, guys. One sec. Okay. All right. Where are we? Okay. Can you see this? This question? Is everyone looking at this question? This is question 6, which I did not solve, which I had prepared. I thought, obviously you can substitute value of x and here and evaluate, but you see there's only 2 points, right? Keep an eye that, there is no one saying that complete the following table of values using the GDC. But we are looking at the GDC, how to solve, and again, I'm not saying calculate using the calculator, like it's just smartly, how to use it smartly, even this thing, like there are 3 integer values of k for which the equation, this is the function, this k has no solutions, just 2 points, and you need to find 3 values. Can you use your algebraic way? Of course, no one's going to stop you. But because the calculator is allowed and there's a smarter way to use it, I think you should. I hope that answers the question.
In the modeling question, it was telling that without any calculation, write a model. So do we lose marks if we show it anyways?
The modeling questions, you can refer to the calculator because, see, anyway, the calculator is allowed. So you don't need to show any calculations because it's assumed that you're using the calculator and students will find the regression equation. Actually, the linear regression is there in the curriculum for 0607. Okay, it is there in the curriculum. So it is assumed that they will be able to use the calculator to find those equations. And I think someone had asked during that part that, can we view the 3 graphs on the same grid, the same set of axes? Once you have the regression equation and it's saved on, let's say F1, F2, F3, something like that, you could use those and, on a graph page, you can have those 3 graphs. If you want to compare the 3 models, if that's the kind of exploration you're doing in your classroom, I don't think that would be a question in the exam. But in the classroom setting, if you want to compare the 3 models on the same grid, yeah, you could do that. Can you explain how is this a new question right now?
Yeah.
can you explain how do we get the equation for the asymptote to a graph? You mean the vertical asymptote? Ria Dubey, vertical asymptote? I'm not able to share again.
Oh, just a
Yeah.
second.
So basically, you go to the table of values, right? So when you go to menu, Jyoti, may I share my screen? Yeah, thank you. So when you go to this was the graph, and so to go to the table, like I said, I mean, the menu is like your lighthouse, but there's another way is that if you just go on the graph and you hit right click, you can see the table here also. It's the same command for that. So that's the graph. And this was the vertical asymptote, and I explained it saying that vertical asymptote is when the function is not defined. So the values of x are here in the first column, the values of y on the second column, and as you can see when it says not defined or undefined, that is where you have a vertical asymptote. So x is equal to 3 is a vertical asymptote, and the other vertical asymptote is x is equal to -2. Okay, Ria? Answers your question?
Okay, so thank you so much, John and Jimmy. Thank you for being here with us today. And we are nearly towards the end of the webinar. And if you need more information or you want to contact us to get the help regarding the technology, you can reach us at the given numbers, or you can also drop us the mails at this mail IDs. Thank you all for joining. Thank you so much.
Thank you all.